What's up everyone, it's me Aydin. Today I'm going to blend up too many things together like system identification, process control, control theory and stuff like that. But basically what I'm doing here is really important. I mean, it takes a lot for the company to realize the things I'm about to show you right here in this video. What is our task? Let's assume that you are given a set of data that represents the input and output of a tank application. Using that set, you have to find out a first-order transfer function because at the end you are supposed to create a properly tuned PI controller. Let's get started. Start by opening MATLAB on your desktop. This txt file contains the input-output dataset I mentioned just a while ago. There are 104 input-output pairs written side by side. Literally, it doesn't matter in which order they are written, because MATLAB will sort them out by itself. Import that txt file to MATLAB's workspace. You can see that MATLAB has already created two columns for input and output sets, named E001 and E000 respectively. From Apps, open the System Identification toolbox. Add the input and output variable names here. Press Import button. Like, no matter how many times you are pressing this button, you are going to get the same data for the next cell. Okay? So let's keep up only with the necessary one. Now it's time to estimate a first order model for a given data set. Select the process models. We know that a first order system should have a single pole. That's why we choose 1 here. If you were to estimate a second order model, 2 would be the one to be taken. Anyways, press the estimate button. We are getting cooler now because we have technically found a first order transfer function for the given data set. I'm going to make some changes on our first order transfer function for further use. Let's substitute all the quantities shown here to the variables. And this is the resulting transfer function. However, I would love to divide both sides by 15 to get the coefficient of s equal to 1. And after that, we end up with this lovely transfer function. Okay. Since we have derived a first-order transfer function, we can now open Simulink to create a simulation of a simple feedback loop to make a properly tuned PI controller. On a blank model, create a feedback system as shown here. You can see a manual switch right over here. For now, I want to neglect the disturbance part of the whole system. Let's keep up with the rest of the circuit. We have a step function generator representing set point. We then have a manual switch to make a transition. A transfer function block that contains the exact same transfer function we derived earlier. But you can ask, where is the TD value though? Well, it's introduced to the system by a delay unit. The scope displays the process variable, the set point, and the controller output for clarity. And finally, the subsystem includes what we are actually looking for. I mean, PI controller. I haven't made any changes on the coefficients. Let's run the program. Damn, something is wrong for sure. Controller output is rocketing to the moon. Set point and process variable are, unreal. This is exactly where a trial and error tuning method comes into play. We have many more advanced tuning methods, such as Ziegler-Nicholas, Cohen-Kuhn, Lambda, and so on. But for now, trial and error method is alright. Let's decrease the proportional gain and see what happens. Okay, much better now. At least we are facing only an unstable system. Let's get rid of the instability by reducing the integral time. Okay, lovely. But I believe we can even get a better result. Let's decrease the integral time even more. That's it. I loved it. Well, SP and PV values have almost zero steady state error. You can see the controller output here as well. We finished, everyone. Let me summarize what you just watched. First, I got input and output data sets from one company, and they told me to tune a PI controller for the first order control system, and I did. Thanks for watching, and if you have any questions, comment down below. I will see you later.